So welcome back. Now let's deal with a linear search. And if we're talking about a linear search, the time complexity of a linear search is going to be big O of n. It doesn't matter if it's sorted or not. We're going through in a linear fashion, one item after the other. Now, the thing is with these lists that we're provided, and we're provided with three different ones, these lists are all sorted. Given that they're sorted, as soon as we find a value in the list that is greater than the search value, we're done searching. So it's a more efficient search than if it was unsorted. So we're saving some time there. Okay, but we do have the time to sort it, or the expense of time to sort it, to be able to get it in this fashion. Now, they provide the main. We've got three different searches we're going to do. The first one, we're going to look for the value 3. We can see that it's in the index of 0. Look for the value of 3. It's not in the list at all. Look for the value of 3. It's not in the list at all. In the second one, we'll reach the end of the list and we'll stop because we've reached the end of the list. In this last one, we reach a value of 4 and we stop because the value that we found in a sorted list is greater than the value that we're searching for. All right, with that said, let's come up here. We need to start by declaring some variable that aligns with the index. Now, I don't want to use the word index, that's a reserved word. Let's call it position. And we'll start with an index of 0. So we're going to start at the beginning of the list. While position is less than the length of the list, I'm going to use a Y instead of an I, because the I is a reserved word if it was in list. So what are we going to do in our list? Well, let's create a condition to see if our target is less than our list of index position. Now, we see target's being passed in, that's our target value, which is 3. Passed in the list. So we've got target and list. And we do that condition. We terminate that conditional statement with a colon. And we'll return the position. And then we'll do an elif. Target is less than list position. So we've got a second conditional on that elif. And on this one, we're going to return -1. So if we haven't found it, It's -1. Come down to the next line, tab back, and we'll increment position by 1 each time we go through. Let's tab back, and at the end of our while, if we've reached the end of that list and we haven't found it, we'll go ahead and return -1. So until we've reached the end of the list, we have two conditions, or I should say two alternatives. Either we find the position, we find target in there, and we return the position, or we don't, and we return a -1. Simple as that. Okay. If we went through all of it and we haven't found it, we return a -1. So let's go through and see what we've got. It says it's got an issue. I've got a typo right here. By saying typo, it's saying position is not defined. Did you mean position? Yes, I did. So it went through, it found it at index 0. Now what if I put a 1 in there? It finds it at index 1. Now let me back up and undo that what I just did so I can evaluate it, and we'll see how we did. It says everything was fine. 1 check. Linear search. Ran it quite fast. Now, I could have passed this function that we created any target value and any size list, and it will perform a linear search, this code right here, on, it doesn't matter if the list is sorted or unsorted, to do a linear search, but for how we've got these conditions set up, it does. This elif right here assumes that this is a sorted list. So with that said, there's something else we can do. I don't want to do it in here because I don't know if it's actually built into this. But in the notebooks that I've got at the start of the course, the refresher Python notebooks, in one of those notebooks is some code. We'll talk about it in a future module, but it's some code to measure the time it takes to complete a task. So we can actually verify the time complexity to a degree to see how much time is it taking to perform these tasks. So we've got this one done. I'll see you in the next one.